This is lesson 7-1, Roots and Radical Expressions. Nth root. For any real numbers a and b and any positive integer n, if a equals b, then a is an nth root. Let's look at what that means in relation to this table. This first column is your type of number, so we're going to be looking at positive numbers, 0, and negative numbers. Second column, number of real nth roots when n is even. And the final column, number of real nth roots when n is odd. So let's look at an example of the number of real nth roots when n is even and your number is positive. For example, if we were going to find all real square roots of 16, all the real square roots of 16 would be 4 and negative 4, because 4 squared is 16, but also negative 4 squared is 16. So notice there are two answers. There are two roots. There are two, that's the number of real nth roots. There are two. Or in this case, the number of real square roots is 2. And so n is even, that would be that we're taking the square root, square being 2, so that's your n, that's even, and then the positive number being 16. So let's look at what happens when it's negative 16. So find all real square roots of negative 16, meaning what number times itself would give you negative 16. There isn't one. There's no number times itself that will give you a negative number. 4 times 4 is 16. Negative 4 times negative 4 is 16, which is why if you're taking the square root, the fourth root, the sixth root, if your n is even, you can't take a square root or a fourth root or a sixth root of a negative number, because that means a number times itself, and that's not possible. Then with 0, if we do the same thing, so if you take the square root or find all real square roots of 0, there's only one, because 0 times itself is 0, so you don't have a positive and a negative option. Okay, let's look at that when the real nth root when n is odd. So instead of taking the square root, you would do the fifth root or the third root, the cube root. So let's look at find all real cube roots of 8. So 8 being our positive number, cube being our n. So we're finding how many roots there are, how many cube roots there are. And in this case, you have just 2, because 2 times 2 times 2 is 8. Negative 2 is not an option, since negative 2 times negative 2 times negative 2 would give you negative 8, which is why you only have 1. You only have one real nth root if your n is odd. So the cube root, the fifth root, the seventh root, the ninth root, there's only going to be one of them. 0, if you take the cube root of 0, 0 times 0 times 0 is 0. Again, you only have one option. There isn't a negative 0, so there's only one nth root. And if it's negative, so find all real cube roots of negative 8. So what number times itself, because it's a cube root, would give you negative 8? Only negative 2. Negative 2 times negative 2 is 4 times negative 2 would give you your negative 8. Not a positive 2, only a negative 2. So if you're doing the cube root, the fifth root, the seventh root, the ninth root, there's only going to be one answer. However, if you're finding the square root or the fourth root or the sixth root, if your n is even, then you have two options as long as you're taking the nth root of a positive number, and of course no options if you're taking the nth root of a negative number, since no number times itself will ever give you a negative number. So let's look at example 1. Find all the real roots. So cube root. So according to our table, there's only going to be one option. We're taking the cube root, so n is odd, which means there's only going to be one answer. But there's always one answer if you're going to take the cube root. There's never the option of none. It might be positive if your number's positive, or it'll be negative if your number's negative. So the cube root of 27,000. Some of you might be sitting there thinking, I have no idea what that is, but others of you, I'm sure, remember this handy calculator here. So just go to your math button, scroll down to number 4 where you're taking the cube root, and enter that number in. And like magic, it tells you what the cube root of 27 thousandths is. So the cube root of 27 thousandths is 3/10, which means that 3/10 times 3/10 times 3/10 gives you 27 thousandths. The cube root of negative 125. So again, math, number 4 gets you that cube root of negative 125, which of course is going to give us a negative number. A negative times a negative times a negative gets you that negative 125. So the cube root of negative 125 is negative 5. And the cube root of 1/64. So again, math, number 4, 1/64 is 2,500, or 1/4. You can change that to your fraction, back to your fraction. 2,500 or 1/4, either is fine. Actually, I'm going to go ahead and put it as a fraction since the problem we were given, it was given as a fraction. So those are your cube roots. Fourth root, so that would be an even root. So back to our table, if we're finding an even, if n is even, so the square root, fourth root, sixth root, eighth root, then we can only find those, they're only going to be real roots of positive numbers, no negative numbers. So this one right here will not have a root, but we can start with 625. Your calculator will also do fourth roots. So you just go to math. Actually, before you even do that, I'll show it to you here, but you have to start with the 4. So that little X right there means that you can put any number there, 4th root, 5th root, 6th root, 8th root, 10th root, 9th root, whatever you want. But you've got to start with the number. So since I'm doing the 4th root, start with your 4, then go to math, and then go to number 5. And since your calculators are updated, it'll actually put that little 4 there for you. And we're taking the 4th root of 625. So what we're asking is, what number times itself, times itself, times itself will give you 625? And that is 5. So again, what we've just answered is that 5 times 5 times 5 times 5 is 625. That's the 4th root of 625. But remember, since this was positive, it has 2 answers. So not only is it 5, but it's also negative 5. So we can say plus or minus 5 for that one. Because negative 5 times negative 5 times negative 5 times negative 5 would also get you positive 625. This negative 16 10,000ths, like we were saying just a minute ago, if you're trying to take an even root, if your n is even, you can't take the nth root, an even nth root of a negative number, because there is no number times itself times itself times itself that'll get you a negative number, so that's just none. And then finally the nth root, or the 4th root, sorry, of 81 625. So again, back to our calculator, do your 4 first, math, it's number 5 of 81 625. Fix that. And let's go ahead and change it to a fraction. So 3 625. Let's see. Actually, maybe I need to close the parentheses on that. I think it just took the 4th root of 81, and it didn't do our denominator. So let's try that again. The 4th root, math, number 5, of 81 divided by 625. And let's see if it'll let us do that. Now it wants me to put the parentheses in the front. So let's go here. Don't think you'll have as much of a problem with this. since your calculators are updated. There we go. Math, enter, enter. And it says 3/5. So if we do 3/5 times 3/5 times 3/5 times 3/5, we'll get 81/625. But also, if we do negative 3/5 times negative 3/5 times negative 3/5 times negative 3/5, since we're multiplying it an even number of times, a negative times itself an even number is going to give you a positive answer. And again, that goes back to our chart. If you're taking an even root, the fourth root, the square root, the sixth root, eighth root, then you're going to have those two answers, the positive and the negative answer. Only with odd roots, like the cube root, fifth root, etc., will you just have one answer with those. Okay, so it's time for you to do your quick check, which means you might want to pause the video so you can get this done on your own and play it when you're ready. Okay, this is quick check 1. It says find all the real fifth roots of 0, -1, and 32. So fifth roots, 5 being odd. I know there's only going to be one answer for each one of these. When you take the fifth root, when you take any root of 0, you're always going to get 0. So on that first one, I know that the fifth root of 0 is going to give me 0. -1 is another one that shouldn't be too tricky. The only thing you can multiply to get 1 is any integer is 1. 1 times 1 times 1 times 1 times is 1. So in this case, to get -1, it must be a -1 times itself 5 times. And then finally for 32, this one you may not have known, but remember that you can use your calculator. We want to do the fifth root, so start with your 5, math, and then it's choice number 5, the fifth root of 32, which is 2. So 2 times 2 times 2 times 2, 2 times itself 5 times will get you 32. And this next quick check, we want to find square roots. That's an even root. Remember that you cannot take an even root of a negative number. So this one will be none or no real square roots. However, with positive numbers, you're going to have a positive and a negative answer choice. So don't forget about those. When you're taking an even root, you'll have two answers for a positive number. But this one we can just do our square root of 1,000th. All real square roots. Now, let's see if we can get a fraction here. See, find all the real square roots. Ah, there's the issue. In your book, it has one more 0. That makes a big difference. So let's try that one instead. Since this gives us a number that doesn't end, that's an irrational number. I want a rational number. So second square root 0, 0, 0, 1. Okay, much better. So that one would be 1/100th plus or minus 1/100th. Of course, you can't take the square root of -1, and then the last one, you just take the square root of the numerator, which is 6, and the square root of the denominator, which gives you 11. Okay, some things we need to talk about before we move on. You may have noticed that these were written kind of weird. You probably thought we should have just been writing the square root of 36 divided by 121. Why didn't we just write it like that? There's a reason for that, because that means something. Let's take like the square root of 16, for instance. This 16 is what you call your radicand. What's under the radical? It has a name. It's called the radicand. So that's the number under the radical sign. This, of course, we call the radical sign. And you know what? I'm going to change this from the square root to the fourth root. So you call that the index. So if I had left it as the square root, your index would be 2, but since it's the fourth root, your index is 4. And when you write a problem like this, what you're asking for is what's called the principal root. And the principal root is the positive root. So when you write something like the fourth root of 16, you're only asking for the positive answer, 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Even though if you wrote find all real fourth roots of 16, that would be positive or negative 2, because negative 2 times negative 2 times negative 2 times negative 2 is also 16. So when you actually put it under the radical sign, what you're asking for is the positive root. So that's the principal root is the positive root when a number has 2 real roots, and it only has 2 real roots when your index is even. So this only really matters with an even index. The radical sign indicates the principal root. If you wanted the negative answer, you could ask for it by putting your negative sign in front of your radical. So you could say, I would like to know what the negative fourth root of 16 is, and that's how you get that negative answer. But just in general, if you are taking the fourth root or the square root or the sixth root of any number, basically what you're asking for is just the positive answer, which is why these problems we were doing just a minute ago were written out not with a square root sign over them, because again, what that means is you just want the positive answer, and that wasn't what we were doing. We wanted to know all the answers. So we were doing an even number, we wanted those 2 answers. Okay, let's look at that with example 2. Find each real number root. So remember, since they've actually put the radical sign, we're just looking for one answer, the principal root. But if you remember back to that table, since we're finding an odd, and since our index is odd, there's only one answer anyway. And if you're not sure what it is, then of course you can go to math. Number 4 is your cube root of negative 1,000. So it's negative 10. For B, again, remember back to your chart. Can you take an even root of a negative number? So what this is asking is, what number times itself is negative 81? Is there one? There is none. No number times itself will give you a negative number. Unlike with A, negative 10 times negative 10 times negative 10 does give you negative 1,000, which is why negative 10 is the cube root of negative 1,000. Okay, time for your quick check 2. So go ahead and pause the video, do all 3 of your quick checks, A, B, and C, and when you're finished, press play. Okay, so we're still looking at finding real number roots, this time the cube root of negative 27. Since we're doing the cube root, we can take the cube root of a negative number. And what we're trying to find out is what number times itself, some number times itself gives us negative 27. What we're trying to find out is, what is that number? So 3 times 3 is 9 times 3 is 27. Negative 3 times negative 3 times negative 3 gives us negative 27, which means that our cube root of negative 27 is just negative 3. B, we're finding the fourth root of a number, and it is positive, so we can do it, the fourth root of 81. So what we're asking is, what number times itself times itself times itself gives you 81. Again, if you don't know how to find that, you can go on your calculator, fourth root, so start with your 4, go to your math. It's choice 5, where you can do the fourth root, fifth root, 10th root, 100th root of any number of 81. And 3 is the fourth root of 81. Square root of 49. Oh, we're used to this. The square root of 49. Doesn't this look nice after all those new crazy problems? The square root of 49, just 7. So keep in mind that when you have this radical sign, that means we're only asking for the principal root, even though there are 2. Negative 7 times itself is also 49. Okay, the nth root of a to the n when a is less than 0. For any negative real number a, the nth root of a to the n is the absolute value of a when n is even. So only when your index is even does this matter. What does this mean? This looks crazy. Don't worry, it won't look so bad with the example. Okay, example 3. Simplify each radical expression. So let's start with the easy part of this. This is a square root, and you know what the square root of 9 is. That's just 3. But x to the 10th. Actually, you know what I'm going to do? I'm going to rewrite this whole thing. So I'm going to rewrite this as the square root of 3 squared times x to the 5th squared, because x to the 5th squared is our x to the 10th. So that when we take the square root of it, the square root of 3 squared, well, the square root and the squared cancel, so that's just 3. And again, the square root and the squared cancel, so we get x to the 5th. But here's the problem. When you substitute in a number, since it's x to the 5th, if this were a negative number, a negative times a negative times a negative, 5 times, that's going to give you a negative, and then you have the square root of a negative, and we can't take the square root of the negative. So that's why we had this little property here, was to say that you have to put it in absolute value, because that tells everybody that that has to be a positive number, since you can't take the square root of anything negative. So everything that's under your radical has to be positive, which means that x to the 5th has to be positive, and so you let people know that by putting your absolute value. Thankfully, it doesn't matter if your index is odd, because keep in mind, we can take the cube root, the 5th root, the 7th root, we can take an odd index root of anything, positive, negative, doesn't matter. So it only matters, like this was saying, it only matters if your n is even. It only matters if your index is even. Then we have to worry about letting people know that this can't be a negative number. So if we're taking the cube root of a cubed times b cubed, the cube root of a cubed, well, the cube a, and the cube root of b cubed is just b. And this could be negative, because you can take the cube root of a negative. So we don't worry with those absolute value signs there. Okay, we have one more to do together, and then you're going to do your quick check. So 4th root, that's an even root, which means we do have to worry about those negative numbers. There can't be any negative numbers under our radical, because we can't take an even root of a negative number. So that's where we do have to worry about those absolute value signs. So I'm going to rewrite this as the 4th root of x to the 4th to the 4th. 4 times 4 is 16. When you raise a power to a power, x to the 4th, that's x to the 16th, and then, of course, y to the 4th. So when we simplify this, the 4th root of the 4th, these 4's cancel out, so you're left with x to the 4th, and the 4th root of y to the 4th, again, the 4's cancel out, so you're left with y. Okay, this x to the 4th. Any number to an even power, whether this is negative, positive, doesn't matter. If this is negative 2, a negative times a negative times a negative times a negative, since it's an even number of times, that's going to be a positive number. So I don't have to put the absolute value around here, because it's going to be positive no matter what x is. If x is negative, you multiply it times itself an even number of times, it's going to be positive. However, this y, since it has an odd root, just 1, if y was negative 2, then I'd have the 4th root of a negative number, which you can't do, so I do have to indicate that y has to be a positive number. So just your y goes in the absolute value. Okay, time for your quick check. Time for you to try this on your own. So pause the video now and work these on your own. When you're ready, press play. Okay, so we're looking at a square root here, and I'm going to rewrite this as the square root of, this would be 2 squared, 4 is 2 squared, x squared is fine, I got those squares to cancel out, and then y to the 4th would be y squared squared. So when we take the square root of 2 squared, the square root and the squared cancels out, you get 2. 2, of course, is positive, so I don't have to worry about absolute value with that. The square root of x squared, the square root and the squared cancel, that's just x. Which, since it has an odd root or an odd exponent, I do have to put it in absolute value to tell everyone that this has to be positive, because if it isn't, then when I take the square root of it, that negative number, then I'm going to be in trouble. So we can't have that. And then the square root of y squared squared, so the squared cancels, and you just get y squared. Of course, any number squared is always going to give you a positive number, so I don't have to worry about putting that in absolute value. Okay, B, cube root. So yay, we love these, odd roots, because with odd roots, you can have negative numbers, so we don't care about those absolute values. The cube root of negative 27, so what number times itself would give you negative 27? That would be negative 3 times negative 3 times, actually, let's rewrite it. Put it under the radical. So the cube root of, so this would be negative 3 cubed. Negative 3 times negative 3 times negative 3 is negative 27. Then this would be c squared cubed, because you multiply the exponents. 2 times 3 gives you 6. That's 2 to the 6. So the cube root of this would be, the cubes cancel out, so that's just negative 3. And again, your exponent 3 and the cube root of cubed, so it's cancel out, and you just get negative 3 c squared. Again, no need to worry about absolute values because you're taking an odd root of something. All right, last quick check for this one. It is an even root, so I do have to watch out for those numbers that could be negative without the absolute value. So let's rewrite this as the fourth root of x squared to the fourth, because I want my fourth to cancel out. 2 times 4 is 8. And then y cubed to the fourth. 3 times 4 is 12, so that's y to the 12th, and I can cancel out those fourth roots. So I have cancel out your fourth root. I have x squared, which means that's always going to be positive. Any number times itself will always be positive. And then y cubed, which could give me a negative number, so it has to go in an absolute value. Remember, this only matters with taking the even roots of numbers, since you can't take the even root of a negative number. Okay, last example. Where does this fit into life? Well, I know that you've always wanted to be a cheese manufacturer, so I just knew that this was going to help you in the future when you start your cheese business. A cheese manufacturer wants to ship cheese balls. That's right, cheese balls that weigh from 10 to 11 ounces. That's important. In cartons that will have 3 layers of 3 cheese balls by 4 cheese balls. The weight of a cheese ball is related to its diameter by the formula, that's important, W equals D cubed divided by 5. So the weight equals the diameter cubed divided by 5, where D is the diameter in inches and W is the weight in ounces. What size carton should be used? Assume whole inch dimensions, meaning whenever you decide what size carton to get, you couldn't order like a 2.3 inch carton. You can get a 3-inch carton because they're not going to sell you a 2.3 inch carton. You're not going to find one anyway to buy. So that's what they mean there. Okay, this looks super complicated. In fact, probably pause the video so you can write this down. Okay, looks really complicated, not that complicated. Let's start with this important piece of information right here, that the weight of the balls is between, the cheese balls is between 10 and 11 ounces. So 10 is the least amount they're going to weigh, to 11, the most amount they're going to weigh, W being your weight. So your weight is between 10 and 11 is what that says. Well, our formula says that weight is the diameter cubed divided by 5. So let's replace W with diameter cubed divided by 5, because I'm trying to find the dimensions. So having the weight, knowing the ounces, that doesn't help me as much finding the dimensions of my carton. So I need to focus more on the diameter. If I can find out what the diameter of my cheese balls is, I can figure out how big my box needs to be. Okay, so I need to figure out what my diameter is, which means I need to solve for D. The first thing you have to do is get rid of this divided by 5. So to get rid of your divided by 5, multiply all 3 parts of your equation by 5, or your inequality by 5. 5 times 10, 50 is less than or equal to, D cubed is less than or equal to 55. Okay, I still haven't found what my diameter is though, because this is my cubed diameter. So to solve for diameter, the opposite of cubing something is cube rooting. So cube root all 3 parts of your equation. And I don't know about you, but I don't know the cube root of 50, so bust that calculator out. Let's go to our math button, cube root number 4, cube root of 50. That's some crazy decimal. Let's go ahead and cut it off at the hundredths place. 3 and 68 is less than or equal to, D is less than or equal to, and then we take the cube root. So again, we're going back to math. Cube root number 4 of 55. And we'll round it to the same place, the hundredths place, so that's 3 and 80 Okay, so what that tells me is the diameter of each one of my cheese balls is somewhere between 3 and 68 and 3 and 8/10 for every cheese ball. Well, since this is not an exact science, we're dealing with cheese balls. We've got to account for that error and go ahead and assume that our cheese balls are all going to be the biggest size, so 3 and 8/10. So let's see. So we have 3 layers of cheese balls, 3 cheese balls by 4 cheese balls. So basically 3 by 3 by 4. So it's 3 layers, boom, boom, boom. In each layer you have 3 cheese balls by 4 cheese balls. So that's our dimensions: 3 cheese balls high by 3 cheese balls wide by 4 cheese balls tall, or whatever it is. And each diameter is 3 and 8/10. So I'm just going to take each one of these dimensions times 3 and 8/10 to find out how big each one of these dimensions needs to be. So on your calculator again, 3 times 3 and 8/10. So that's 11 and 4/10, and then 4 times 3 and 8/10, 15 and 2/10. So 11 and 4/10, 15 and 2/10. That's again 11 and 4/10. 11 and 4/10 what? So your diameter is in inches. That's 11 and 4/10 inches by 11 and 4/10 inches by 15 and 2/10 inches. But remember, you can only use whole inch dimensions. So if you need your box to be at least 11 and 4/10 inches, you've got to go up to that next whole number inch, 12 inches by 12 inches by 16 inches. Okay, if you follow these steps, then you should be able to do yours on your own. And actually, the quick check is a little bit easier. Go ahead and pause the video so you can work on it. When you're ready, press play. All right, so we're using this formula where D is the diameter and W is the weight in ounces. We're trying to find the diameter if it weighs 3 ounces. The weight is 3, so substitute 3 for W equals D cubed divided by 4. So we're trying to solve for D. The opposite of dividing, multiplying both sides. 4 times 3 is 12 equals D cubed. How do you solve for D cubed? The opposite of cubing, cube rooting. So cube root both sides. And the cube root of 12 is 2 and 29 inches. And your other 2 quick checks work the same way. So good luck and prepare for this quiz when I get back.